Okay, so this is really messing up my flow. I like to continue without pausing and stopping the video, but I'll get it fixed next week. This week, we're just going to have to deal with it, right? So here, I made my error worse, right, by using x and x plus 2h. Can I make this better? Is there any way I can make this a better approximation? And the answer is yes, right? We have to pick different points, and we're going to use something. We're going to use something called the midpoint difference formula. The midpoint difference formula. Midpoint difference formula. So I want you guys to recall that function that we put on the board before, right? It's still up there. Suppose that this is x, right? And suppose that instead of us thinking of forward difference going forward in time or backwards difference going backwards in time, right? Let's suppose that x was our mid time, right? So we have a previous time, let's call it x minus h, and past or future time, which we'll call x plus h. Okay. And and we're going to use these two values, x minus h and x plus h, to create a secant line. Okay. And we hope that the slope of this secant line is approximately the slope of the tangent line. Do we actually get a better approximation using this midpoint difference formula than we did with the forward difference formula, or the x and the x plus 2h, which is also another forward difference formula, but even worse, right? And the answer is yes. So how do we find this midpoint difference formula? So let's do that. To find it, we need to find the Taylor series, or compute the Taylor series of f of x minus h and f of x plus h. We need to find out what these two Taylor series are. So let's put them both down. We want to find a Taylor series of f of x minus h and f of x plus h. F of x minus h is equal to f of x plus f prime of x times negative h. Good. Plus f double prime of x times negative h squared divided by 2 factorial plus f triple prime of x times negative h cubed over 3 factorial. If I wanted to, I really can write them just like this, right? I can say f of x minus h, just to simplify it just a little bit, is f of x minus f prime of x times h plus f double prime of x times h squared over 2 factorial minus f triple prime of x over 3 factorial times h cubed, right? That's the same thing, plus that. That's f of x minus h, the Taylor series for it. The Taylor series for this guy. F of x plus 2, f of x plus h, okay, can't talk today. It's going to be equal to f of x, we've already seen this before, plus f prime of x times h plus f double prime of x times h squared divided by 2 factorial plus f triple prime of x over 3 factorial times h cubed. So here's our guy. And you're like, why did you do that, Dr. Wesley? Why do we have both of these formulas on the board? Okay. And I say to myself, remember what we were trying to do before? We were trying to solve for f prime right? We're trying to solve for f prime of x, right? And I wrote down both of these two formulas, these guys right here. Are going to allow me to come up with this midpoint difference formula. Notice that both of these formulas have f prime of x, right? And what I'm going to do is I want to combine these two formulas together, right? So that I can solve for f prime of x, right? Now notice that if I were to add these two formulas together, if I were to add these guys together, if I were to add f of x minus h and f of x plus h, these two series together, if I were to add these guys together, my f prime of x is going to disappear. It's going to go away, which is not what I want. I don't want it to disappear or go away. So if I add these guys together, I can't solve for f prime of x. That's bad. So what can I do instead of adding these two functions together? What can I do instead? Well, I can subtract them, right? I can subtract these two guys. So that's what I'm going to do here. Now, which one goes first? Well, it really doesn't matter. If I'm going to do f of x plus h minus f of x minus h. Okay. So I'm going to do f of x plus h minus f of x minus h, right? So I'm going to do this one minus this one. So these two terms are going to disappear, right? Can you see it? These guys are going to go away. These two terms are going to become 2 times f prime of x times h. Okay. What's going to happen in these two terms when I subtract them? They're going to disappear, right? You see it? What's going to happen to these two terms? I'm going to add them together, right? And I get a plus 2 times f triple prime of x over 3 factorial times h cubed, and it goes on, right? Right, when I added these two guys together. Now let's solve for f prime of x. It's still there. So if we solve for f prime of x, this is what we get. F prime of x, so we have 2 times f prime of x times h is equal to, here we have f of x plus h minus f of x minus h minus 2f triple prime of x over 3 factorial h cubed, and so on. Or minus, whatever. And now I want to get f prime of x by itself on one side, so I divide by 2h. So I get f prime of x is equal to f of x plus h minus f of x minus h. Notice that there's no h's being multiplied by, so I'm going to put it all underneath it, divided by 2h. So I get this. Minus, I'm going to divide by 2h here, so this 2 is going to cancel. One of these h's is going to cancel. I get f triple prime of x over 3 factorial h squared. Here is going to be my approximation. And what's going to be my error? It's going to be right here. This is going to be my error. So my midpoint formula looks like this. I have f prime of x is approximately equal to f of x plus h minus f of x minus h over 2h. And notice that this error is actually much smaller than the ones I had before. I erased it, but